Measurements is determination of the size or magnitude of a physical quantity. It is the process of determining the size, magnitude of an unknown physical quantity by comparing it to the standard quantity. Is the collection of numerical or quantitative data that describe a property or event. A measurement is done by comparing a physical quantity with a standard unit. Physical quantities. Physical quantities. A physical quantity is quantity which can be measured. For example, length, mass, time, temperature, electric current, light intensity, volume and many others. A physical quantity is always measured of natural non-living objects. Physical quantities have numerical magnitude and unit. For example, if the length of a student is 104 centimeters, then 104 is its numerical magnitude and cm is the unit of measurement. Physical quantities. Another example of physical quantity is that when a grocer says that each sugar bag contains 5 kilograms, he is describing its numerical magnitude as well as the unit of measurement. It would be meaningless to state 5 a kilogram only. Physical quantities are of two types. 1. Base quantities. 2. Derived quantities. Base quantities. Base quantities are the quantities on the basis of which other quantities are expressed. There are 7 base quantities which include length, mass, time, temperature, intensity of light and amount of a substance. Derived quantities. Derived quantities are the quantities which are expressed in terms of base quantities. These include area, volume, speed, force, work, energy, power, electric charge. SI units. SI units. International System of Units. What is unit? Once a standard is set for quantity, then it can be expressed in terms of that standard quantity. This standard quantity is called a unit. The 11th General Conference on Weight and Measures held in Paris in 1960 adopted a worldwide system of measurements called International System of Units. The International System of Units is referred as SI. Base units and derived units. The SI unit contains base units and derived units. Base units, the units that describe base quantities, are called base units. There are 7 fundamental base quantities and units, which are: length as quantity with a unit of meter, mass with a unit of kilogram, temperature with the unit of Kelvin, time, seconds, amount of substance with the unit of moles, electricity current, its unit is ampere, luminous intensity, it candela. Base units and derived units. Derived units. Derived units are the units used to measure derived quantities. It is obtained from the combination of 2 or more basic units. For example, velocity, its units meter per seconds. It derived displacement over time. Displacement, length and time are basic quantities, which have basic units of meter and second respectively. Other derived quantities and their units: volume, its liter, force, Newton, pressure, Pascal, energy, joule. SI prefixes. Prefixes are the words or letters which we add to the beginning of a word to make a new word. For example, the word unhappy consists of the prefix un, which means not, combined with the stem word unhappy, means not happy. SI units have advantage that the multiples and sub-multiples can be expressed in terms of prefixes. Prefixes. Tera equals 10 raised to power 12. Giga equals 10 raised to power 9. Mega equals low raised to power 6. Kilo equals 10 raised to power 3. Hecto equals 10 raised to power 2. Deca equals 10 raised to power 1. Deci equals 10 raised to power -1. Centi equals 10 raised to power -2. Milli equals 10 raised to power -3. Micro equals 10 raised to power -6. Nano equals 10 raised to power -9. SI prefixes. Note that the kilogram is the only SI unit with a prefix as part of its name and symbol. Because multiple prefixes may not be used, in the case of the kilogram the prefix names are used with the unit name gram, and the prefix symbols are used with the unit symbol g. With this exception, any SI prefix may be used with any SI unit, including the degree Celsius and its symbol degree C. Scientific notation. Scientific notation is a way to write large or small numbers with some power of 10. Scientific notation has a number of useful properties and is commonly used in calculators, by scientists, mathematicians and engineers. For example, a number 62,750 can be expressed as 6.275 times 10 to the power of 4 or 0.6275 times 10 raised to power 5. All these are correct but the number that has one non-zero digit before the decimal. For example, 6.275 times 10 to the power of 4 preferable be taken as a standard form. Similarly, the standard form of 0.00045 seconds is 4.5 times 10 to the power of 4 seconds.